All right. So we got a combination circuit right here. We're going to follow these steps. These are the steps. Number one, you want to redraw this thing just to make your life a little bit easier. So we've got a 100. We've got a 100 and a 300 here. So now some of you might not like to draw it, redraw it, but I think it's going to help. So if you go like this, and then you just put the 100 ohm and the 300 ohm on each side, it may make your life a little bit easier. So we redrew it. Calculate the total resistance of the parallel circuit. So the total resistance of the parallel circuit, 1 RT is equal to 1 over 300 plus 1 over 100. So this will be 3 over 300. So 4 over 300. So the inverse of 300 over 4, that is, trying my brain, 75.
Yep.
Everybody with me? Okay. So one thing we can say is that this total resistance right here, very poorly drawn, is 75 ohms. That's an ohm symbol for the people at home. All right. I'm going to erase this real quick, which means to erase again. All right. Calculate the total amps. Now we have these guys in a series. We have a 75 ohm and a 200 ohm resistor in a series with 120 volts. V equals IR. 275 is the total ohms. 120 volts equal to I. That is 0.436 amps. Does everybody agree with that? You agree with that? I just did that, I just knew that because I just watched somebody solve it back there. I didn't pop that one out my head that quick. All right, 0.436 amps here, 0.436 amps here. Who cares? Anywhere outside of this little parallel is 0.436 amps. Next thing, calculate the voltage drop of the series resistor. So we're going to go to this guy right here, and we're going to calculate the volts of just this guy. So there's 0.43, well, V equals IR, 0.436 amps at 200 ohms. That is 87.2 volts. Is that right? What'd you get? 87.3 volts. Right here. So this guy right there is taking 87.3 volts of the 120. So now we know what's left over. Calculate the voltage drop of the series resistor. Calculate the voltage drop of the parallel resistor. All right? So now we know this guy right here, there's only 120 volts available, minus 87.3 are already used by this guy. So how many volts are left, everyone? 32.7?
Yeah.
Sounds good to me. 32.7 volts is the total voltage drop. So now, everything's gone. Everything's done. We're just looking at this parallel resistor. Both of these, parallel circuit. Both of these resistors have equal access to 37.2 volts. So now we can calculate the amperage on this side, and we can calculate the amperage on this side. And it should add up to the total amperage. All right? So, let's try it. V equals IR right here. We got to use this voltage right here. V equals IR. 32.7 volts is equal to how many amps with a 100 ohm resistor? So we're going to say 32.7 divided by a hundo. 32.7 divided by 100 is 0.327. 0.327 amps. You can either solve the next one or you can just subtract these two. Does that make sense? We'll just go ahead and solve it here. Now we have 32.7 volts is equal to what current with a 300 ohm resistor? 300 ohms. What does that give you? 0.109? Just guessing? Okay. 0.109 amps. So now everything about this series has been, everything about this combination circuit has been solved. Anybody have any questions?